hopefully not break down. So it was 6.02 times 10 power 23. That meant a big number, right? And it's a unit for counting. You can count anything using that. It's like dozens. Like you've got 1 dozen, 2 dozen. You've got 1 million, billion, trillion. So all these are units of counting. And I told you that you count atoms in moles. The reason you count atoms in moles is that there's so many of them. You've got lots of. So what you have is you've got lots of atoms, right? If you have got 1 mole of atoms, that's a big number. That's a lot of atoms. So everything is counted in this unit, which is moles. So if you have 1 mole of atoms or 1 mole of molecules or 1 mole of electrons, that's this many atoms or molecules or electrons. So the first thing that we were trying to do is we're going to link it up. We were linking it up with equations. I told you everything will be counted in moles. So if I have an equation, like I've got NaOH reacting with phosphoric acid, that's H3PO4. Now this one is an acid-base reaction. So I'm going to first make the reaction. You've got the OH ions and the H positive ions from the acid. They're going to combine to form water. That's the first thing that will happen. And whatever ions are remaining, they're going to form the salt. So the sodium and the PO4 over here, they are going to form the salt. So PO4 has a charge of -3, sodium has a charge of +1. So the salt that's going to be formed is going to be Na3PO4. And that's my equation. So that's the first thing. I've got my equation. And I would have to balance the equation. I'm going to rub off everything else. Take all my working. So I'm going to have the equation first. I'm going to balance it. Remember, I can't change the formulas once the equation is balanced. I can't change the formulas. So if I want to balance it, there's 3 sodiums, right? So I'm going to multiply this by 3. And how many hydrogens do I have? I've got 3 over here, and I've got just 1 hydrogen over here, but there are 3 molecules, so that's 3 hydrogens over here. So 3 plus 3, that's 6 hydrogens. So if I have 6 hydrogens, I would have to multiply this by 3. I said the P is balanced. You got 1 P and you got 1 P over here as well. That's already balanced. The oxens, 4 oxens, 3 over here, 3 oxens over here. There's 3 oxens over here, so that's also balanced. Everything is balanced. So I've got a balanced equation. I said last time, this is what we were discussing, that once you have an equation, the equation is like a recipe that 3 sodium hydroxide molecules, they react with 1 phosphoric acid molecule, and they produce 1 sodium phosphate, and they're going to produce 3 water molecules. So that is the recipe. One of this is mixed, and the result is you're going to get 1 of this and 3 of these. So all equations are like a recipe. So, and they have a certain ratio. Everything has to be mixed in a certain proportion or certain ratio. So I told you that this, in a balanced equation, gives you the simplest ratio. It has the simplest ratio in which the molecules and compounds are going to react with each other. So 3 reacts with 1. So agar mere paas 6 NaOH honge, how much phosphoric acid do I need to react with it according to the ratio? Like 3 needs 1.
2.
6 according to the ratio would need 2. And you can work this out. You can work it out simple ratios. 3 reacts with 1. So how much would 6 react with? It's going to be x, and you can cross multiply, and it's going to come out to be 3x would be equal to, I said 3x would be equal to 6, and divide by 3, it's going to give you 2, right? So that's where you get 2. I said similarly, what you'll also have is, if I want to find out if 6 NaOH are reacting, how much phosphoric, so this thing will be produced. So 3 produces 1, 6 will produce how much? So I'm going to use ratios again. So I know that 3 of NaOH produce one of this. So 6 of them will produce how much? So again, it's going to come out to be the same thing. It's going to be X would come out to be equal to 6 by 3, and that's going to give you 2. अच्छा, इसका क्या answer आएगा? How much, if I react 6 NaOH, how much water molecules will be produced?
6.
Okay, exactly. So it's going to be 6 because 3 produce 3. 6 will produce exactly 6. So that's the first thing that you have to understand, that you're going to count atoms in moles. So if you're given 6 moles, they're going to react with 2 moles of this, and the product that is going to be produced is going to be 2 moles of this and 6 moles of this. So all equations, you've got to learn how to use ratios. Okay, that's most moles questions are pretty much just ratio questions. Just one second, let me. So most of these moles questions are just ratio questions. Just one second. So I'm going to do another equation, and this time make sure you have a calculator with you. Now this other equation is, it's I think I gave you this question last time. It's 6 NaOH reacting with 3 Cl2s, and let's say the equation is already made for you, so you don't have to worry about the equation. So they're saying that 5 NaCl molecules are produced, and 1 molecule of this thing is produced, and there are 3 water molecules that are also produced. So the equation is already in front of you. So that's like a recipe. That means 6 NaOH react with 3 Cl2 molecules, and they produce 5 of this, 1 of this, and 3 of this. And remember, you're looking for the coefficient. You're not looking at the formula. It's 6 NaOH reacting with 3 molecules of chlorine and producing 5 molecules of NaCl. There's agar number nahi likha hua, that means 1. So can anyone tell me, if I have 0.25 moles, like in my recipe, if I start cooking this thing up, okay, 6 of this reacts with 3 and they produce all of this, right? So if I use 0.25 moles of NaOH, how many Cl2 molecules do I need for this? Yeah, I'm going to use ratios. 6 reacts with how much? 3. 6 reacts with 3. So 0.25 moles should react with how many Cl2s? That's going to be X. 6 reacts with 3. 0.25 should react with how much? That's X. And if I solve for
0.05.
That's a basic expression. It's going to be 3 into 0.25.
0.125.
Yes.
So I'm getting 0.125 moles. Remember, our unit is moles. It's not thousands, it's not billions, it's not dozens. We're counting everything in moles. It's going to be USA color 3 into 0.25, and the whole thing gets divided by 6. Right. What about how much NaCl will be produced? I can pick any 2 ratios, right? Like 3 produces 5. 0.125 produces X. So यहाँ पे कर लेते हैं, it's 3 produces 5, and 0.125 will produce how much? It's going to be X. So what do I get for X? Cross multiply, it's going to be 3X is equal to 5 into 0.125, and get rid of the 3. What do we get?
0.625.
0.625?
I got 0.208.
0.208 looks more correct. What was after 8, by the way?
A lot of 3s.
Okay, so round most things up till 3 significant figures. You don't have to write the whole thing. Round it off on the third number. And remember, you could have picked. I mean, I picked this ratio. 3 produces 5. 0.125 produces x, right? Even if I had compared this ratio, I would have gotten the same number. Okay, 6 of this produce 5 of these, right? So 0.25 will produce how much? It's going to be x. If you try to solve that, it's going to give you the same number. Okay. If I had, so you could compare any two ratios. It's going to be the same thing. It's going to give you the same result. So I said next one is, okay, I've got, I said next one is 5 ratio. So we've got 5:1, right? So I want to figure out how much LaClO3 is produced, right? So it's going to be, you could pick any ratios. 3, iska nikalna hai, so you have to use this ratio, but compare it with any one of them. So I can start with, I can compare the first one, 6:1. So 0.25 ratio x. 6 NaOH produce one of this, right? So 6 produces 1. So 0.25 is going to produce x. And we can cross multiply, and it's going to be 6x is equal to 0.25 and divide by 6. So what do we get for this? In this case, I'm using this ratio, 6:1, 0.25 ratio, the unknown x. So what do we get for this?
0.042.
0.042, right? So for this one, you're getting 0. So make sure everyone has a calculator, 0.042, right? Moles. Since we are counting everything in moles. Acha, iska directly, can anyone answer directly? How many water molecules are produced?
3.
3 is the ratio. Like if you had 3 Cl2s, then 3 water molecules will be produced. I mean, that's the simplest ratio. You don't have to, remember, you don't have 3 Cl2s. You have how many? You've got 0.125 moles. But इसी तरह ना कि हाँ, अच्छा remember कि वो the ratio is going, I mean, the equation is going to be the simplest ratio. It's like one car has how many tires? It's got 4 tires, right? But if you have 20 cars in a parking lot, how many tires would you have? You're going to have 80 tires, right? So the equation is going to give you the simplest ratio. So you're not going to depend on this 3. It just tells you the simplest ratio. Okay, what's the simplest ratio? So example, like one car has 4 tires. So if you have 20 cars, you're going to have 80 tires. So the answer is not going to be 3. It's going to be 3. I mean, let's pick this ratio because that's going to be the simplest. 3 Cl2s, they produce how much water molecule? They produce exactly the same amount of water molecules. So if you've got 0.125, so agar aap ratio bhi lagao na, it's going to give you 0.125 moles. I mean, you can do this. 3 produces 3, so 0.125 will produce x. It's going to be the same thing even if you cross multiply. But remember this thing, to find this out, you could have used any ratios. You could have compared it with this one. Okay, 1 produces 3. So 0.42 will produce how much? It's going to be x, and you can cross multiply and you can find this value. It's going to come out to be exactly the same value. Is this clear?
I don't understand.
What's all about?
It's because for the first part of the lecture I couldn't hear well, so I joined again. So I can't. So I missed a lot.
We're just, but you can hear me clearly now, right? अभी सही है?
जी अभी सही है, लेकिन पहले आवाज नहीं आ रही थी.
अच्छा.
So I left and then I joined again. So I
चलो.
missed a lot of.
नहीं, मैं repeat कर रहा हूँ, ठीक है? Let's do another question. Okay, I was basically, what we were basically doing was, what we were basically up to was, okay, I said, let's do another question. I told you that any equation, you see any equation, let's say we don't care. Okay, let's say the equation is already with us. They've given us this equation. I'm saying all moles questions are simple ratio questions. Okay, they're just ratio questions. If you've done basic ratios in math, an equation is like a recipe. It's what is the recipe telling us? It's telling us that 4 sodiums, they react with 1 oxygen molecule. If there is no coefficient in front of it, that means it's 1. There's just 1 oxygen molecule. And they end up producing 2 sodium oxide molecules. So every equation is the simplest. It's the ratio of the reactants. It's the ratio of the recipe. If you want to make a cake, it's you add 1 cup of flour with 2 eggs, you mix 2 eggs, then you add 4 spoons of sugar to it. So that's a ratio, right? So it's like a recipe. It's 4 reacts with 1, and they end up producing 2 of these. So, and remember, these are not your moles. Your quantity can be different. Okay, but the ratio will still apply. Well, example, like the simplest ratio is 1 car has 4 tires, but if you've got 20 cars, that means you've got 80 tires, right? So let's say you've got 0.15 moles of this. So if you've got 0.15 moles, okay, this is the quantity of sodium that you have. How much oxygen will be needed to react with it? It's 4:1, right? So you'll just use ratios. 4 reacts with 1. So 0.15 moles will react with how much? It's going to be X. Cross multiply. What number do you get over here? क्या आ रहा है यहाँ पे जल्दी से बताओ?
0.0375.
So you're getting 0.037. Veena, is this clear?
Yeah.
Similar,
How did we get 0.15?
I said that's we're not talking about this. Let's say you had 0.15 moles already.
Oh, okay.
ठीक है, मतलब एक beaker है कहीं पड़ा हुआ है, ठीक है, and that beaker has 0.15 moles of sodium, and you're trying to
Okay.
figure out how much oxygen should I mix with it. So it's going to be 0.0375 moles, right?
Yeah, okay.
नहीं उर्वा अभी वो clear है ना कि right now we're just assuming that I just found 0.15 moles of sodium somewhere. ठीक है, so don't worry about where did we get this. ठीक है, I mean there was a अच्छा, so how much sodium oxide will be produced if these two react? Now you can either use this ratio 1:2, 0.0375 ratio X. You can compare any two ratios. You can compare this ratio 4:2 and 0.15 ratio X. So if I like compare the 4:2, so 0.15 will produce how much? So it's going to be 4:2. So 0.15 will produce how much? It's going to be X. So what answer do I get?
$0.075.
I'm getting 0.075 moles for this. And it doesn't matter. It's going to be the same answer if you had compared this one, 1:2, 0.037. So I would have gotten the same answer, 1:2, 0.0375 ratio X. That will give me exactly the same answer, 1:2, 0.0.
Yeah.
So it doesn't really matter which two ratios you pick. It's going to be the same result. So now most moles questions are going to be exactly the same. You find the moles of one thing and you can figure out the moles of everything, all the moles, all the substances in the equation. But the thing is, you need at least the moles of one substance. So let's do another equation. I've got ammonium, let's say phosphate, and it's reacting with calcium hydroxide, CH2 plus, OH is -1, and the product is going to be calcium phosphate, CH2 plus, PO4 is -3. And they're going to do what? They're going to produce, they're going to react and form water and NH3. And it's So let's balance this. 3 calcium's the easiest ones first. BO4s, the 2 of them on that side. So 2, and this is going to be 6 water and 6. So let's say the equation is given. So 2 reacts with 3 of this. They produce 1 of this. They produce 6 of this, and they produce 6 of this. So अगर इसके दिए में, let's say I've been given 0.06 moles of this. That's already given. That I have 0.06 moles of calcium hydroxide. So how much ammonium phosphate will be needed for this? क्या होगा 3 ratio? What will you get for this? This one. You question mark. Tell me what the answer to this is. It's 2:3. X
0.04.
Achha, X ratio 0.06. Achha, anyways, it comes out to be 0.04 moles. Achha, now the trouble is that one thing that you'll find kind of tedious is that every time you have to sort of use ratios, right? So there's a quick method of doing this as well. 0.04 answer aa raha hai, theek hai? But is this clear to everyone? Hanya, is this clear? Noor, is this clear?
Yeah.
Yes, sir.
But now the quick, so there's a hack to it, which is that you don't actually have to do every time you have to do this crisscross. It's going to take a very long time. The easier method for this is instead of doing that ratio thing every time, instead of doing the ratio thing, I want to figure out the moles of this. Now, in any equation, this is how the question would, in most cases, look like. In most equations, you'll know the moles of one of the substance, at least one of them. For example, in this case, I know the moles of this thing. What I just need to do is, this is the quicker way of doing ratios. Take these moles, divide it by its ratio, and multiply it by the ratio of the other substance. Okay, that's the quick. I mean, instead of like writing everything down, the quick way is, if I want to find the moles of this thing, take the moles, the known moles, 0.06, divided by 3, multiply it by its ratio. So it's going to be 0.06, divide that by 3 and into 2. And that's going to give me, so that's one quick hack of doing ratios instead of actually writing it every time and then doing crisscross and everything. Just take the moles of 0.06, divide by 3 into 2. If I want to find the moles of this thing, 0.06, divide by 3 into 1. So it's going to be 0.06, divide that by 3 and multiply by 1. If I want to find the moles of this, it's going to be 0.06, take the known ones, divide by 3, divide it by its own ratio, multiply it by 6. So it's going to be 0.06, divide by 3 times 6. If I want to find the moles of this, it's going to be 0.06 divided by 3 into 6. So in this way, you kind of, things become much quicker, much easier. I mean, you don't have to like write the ratios every time. You can just do that in one go. Okay, but एक के moles पता होने चाहिए, ठीक है? You'll know the moles of any one of the substances in the equation. Take that, divide it by its ratio, multiply it by the other ratio, you'll find that. 0.06 divided by 3 into 1, that gives you this moles. 0.06 divided by 3 into 6, you get this moles. So is this clear? Kya numbers are there? You're getting 0.04 moles for this?
Yes, sir.
And I think, what do you get for this? 0.03 moles? And I guess this is 0.12 moles. And this one is correct me if I'm wrong, it's this one is probably 0.12 moles as well. Okay, so even in the previous one, like you knew the moles 0.15. So instead of doing all the working, you could have made things faster. It's what if I want to find the moles of the if I want to find the missing moles, it's going to be 0.15 divided by 4 into 1. I'll get this. This one is going to be 0.15 divided by 4 times 1. If I want to find this one, I compare it with this one, 0.15 divided by 4 into 2. Divided by 4 into which is I'm going to get the same answer, but it's a lot faster. Okay. So this one is recommended because you'll be much quicker this way. So let's do another equation. Let's say I've got potassium oxide and reacting with phosphoric acid. The H and O react to form water, and what's left is K and PO4. K is +1, PO4 is -3, so it's going to be K3PO4. You got to balance this equation. If you balance it, it's going to be this multiplies by 2. This multiplies by 3. That balances out potassium. You got 2PO4, so this thing gets multiplied by 2. And there's going to be 3 water molecules. Anyways, this equation is already balanced. So the ratio is 3, ratio 2, ratio 2, ratio 3. I said now what I'm going to do is Abu quick karna, we have to be quick. So I've got sometimes the moles are going to be in standard form as well. So let's say I've got 1.2 times, they've already given me 1.2 times 10 power minus 3 moles of this. So how many moles of phosphoric acid will react with it? It's going to be 1.2 times 10 power minus 3 divided by 3 times 2. So this thing gets divided by 3 and then it gets multiplied by 2. If I want to find out the moles of this thing, it's going to be 1.2 times 10 power minus 3 divided by 3 into 2, which is kind of the same thing. So divide by 3 times 2. If I want to find the moles of this thing, it's going to be 1.2 times 10 divided by 3 into 3, which will kind of cancel out. So divide by 3, I mean the 3's are going to get cancelled out. Is this clear? The quick method of doing ratios, is this clear?
Yes.
Okay, Baki clear, Urva? Soeb? Is this clear? Abdullah, is this clear?
Yes, sir.
I said now, remember we were counting. Now what I'm going to do is, I said now remember this, most moles questions are pretty much the same thing. It's if you know the moles of any one of the reactants or the products, you can just use ratios and you can figure out the moles of all the other substances. Okay, so if you know the ratio, you can figure out, I mean, most moles questions are your car wala example. And okay, you got like if you want to make a car, it's ratios, right? It's 4 tires, you need 4 tires, you need 4 doors, right? You need one, what else do you need? You need one steering. And let's say that kind of makes one car, right? So it's like a ratio. It's like so this is like a ratio. So most questions are going to be very similar. It's that 4 of this react with or combine with 4 of this, and they need 1 of this, and then they end up making this product, right? So if you have let's say 80 tires, So how many doors would you need for that? It's going to be 80 divided by 4 into 4, right? How many steering wheels do you need? 80 divided by 4 into 1. So this is quick ratios. It's how many cars will be made by that? 80 divided by 4 into 1. Here, that's a quick way. So most chemistry equations are going to be similar to this. I say, is this clear? This first part, you clear, Saroko?
Yes, sir.
Just remember, we're counting everything in moles, just like we count eggs in dozens, just like we count other things in billions, something in millions. We count every atoms and molecules in moles. Okay, that's a unit for counting. Now, we're going to move towards formulas. Now, that's the basic. Now we come back to the question: how did we find out you had these many moles? Like, who was the? I mean, I told you moles is a big number, right? So let's imagine, okay, I've got three shapes. Just hold on a second. Achha, so let's imagine that I've got a beaker, and that beaker has some sodium in it, right? I've opened my lab and there's a beaker that contains sodium in it, or any substance. Now the question is, how do we figure out? How do we count? Like, how do you count? Let's say there's a small container that's got apples in it, right? So let's say there's this small container and it's got a bunch of apples in it. So यहाँ पे ना there's oranges का, let's say, ठीक है, oranges are. So let's say it's got oranges in it. So the question is, how do we count stuff? There's the many methods of counting, right? One of the method is you count one by one. This is the first orange, this is the second orange, this is the third one, this is the fourth one, fifth, sixth, seventh, and eighth. So I figured out I've got 8 oranges, right? So that's one way of counting things. But counting oranges kind of becomes very problematic if you've got a truck that's full of oranges. So let's imagine you don't have 8 oranges. You've got this huge truck, and that entire truck has so that entire truck has, so it's a big truck. It's an 18-wheeler and it's full of oranges, right? And these are these tiny oranges. It's completely full of those oranges. And now you don't have 8 oranges. You've got a lot of oranges now, right? So it's a truck that's full of oranges. And that's my truck. An 18-wheeler. So if I start counting them one by one, like I pick one, then I pick the second one, then I pick the third one, that's going to take a very, very long time. So can anyone tell me how can I estimate how many oranges I've got? Like what is a good way of counting oranges? Like if I've got an 18-wheeler that's full of oranges.
You can round them, I guess.
क्या कर सकते हैं?
Never mind.
I said, but do you get the problem? What's the problem here? Like counting small things, that's easy. Like it's small, you just count 1, 2, 3, right? But if something is in a very large quantity, it's very hard to actually count the stuff. Okay, the problem समझ आ रही है? What's the problem? Frida, is that the problem? Is that clear? Noor, is that clear?
Yeah, yeah.
Yes, sir.
Okay, so we've got a problem now. So what's the solution to that? How do you count things that are in such large quantity, right? So the easy method is, this is the easy method. You measure the mass of all the oranges. Let's say it comes out to be 3,000 kgs, right? Now, is that clear? I mean, measuring the mass is easy. Like you can just measure the mass of the entire stuff, right? So it comes out to be 3,000 kgs. That's the total mass. Then you pick one orange and you try to figure out what is the average mass of an orange. Let's say the average mass comes out to be 1 kg. That's the mass of, I mean, I'm just hypothetically speaking. So let's say one orange has a mass of 1 kg. So how many oranges do I have?
3,000.
Okay, so that means I've got a total of 3,000 oranges. Although that's an estimate. I mean, it's not going to be 100% accurate, but I'm pretty close to the actual number. Because the actual number, no one is going to actually be able to count all those oranges, right, one by one. So we can just make a very good estimate about how many oranges we've got. So I took the average mass of the orange and I took the total mass of all the oranges in that container, right? And I figured out that if the entire stock has a mass of 3,000 kg and one of the oranges has a mass of 1 kg, that means I've got 3,000 oranges, right? So is this clear? This thing?
Sir.
But the idea clear, okay, you can count, this is another way of counting or estimating the number of oranges you've got. Is this clear?
Yeah.
Achha, and that's the same exact problem that we face with atoms as well. Because how do you count 1 mole of atoms? 1 mole, I told you, is a very big number. It's got 23 zeros in it. That's a big number. That's a lot bigger than a trillion. Trillion only has 12 zeros in it. So when I say that I've got 1 mole of something, that's a number that's a lot bigger than a trillion. If I say 1 mole of atoms, that's more atoms than a trillion atoms, right? So I use kind of the same strategy when I count atoms. Like they're so tiny and there's so many of them. Okay, so atoms. So you've got, like, you pick a piece of sodium and it's got all these billions and trillions of atoms, right? Small atoms. So how do I count those atoms? What I do is I take the total mass and I pick this one tiny atom, this one very tiny atom, this one, and I measure the mass of that tiny atom. So I'm going to divide it by the, so what I'm going to do is I'm going to divide it by the mass of one atom, right? So all I need to do is I need to just very accurately measure the mass of one single atom. If I'm able to do that, I can count the total number of atoms. I'm going to use the same exact strategy to count the number of sodium atoms I've got. I'm going to take the total mass and I'm going to divide it by the mass of a single atom. The mass of a single atom has been accurately measured and it's given in the pure table. Okay, this value is already given, it's provided to you in the pure table. So all you have to do is, if you want to find out how many moles you've got, just take the total mass, use the same orange strategy, take the total mass and divide by the mass of the single atom of sodium. And you'll be able to figure out how many atoms you've got. Okay, is that clear?
Yeah.
Yes, sir.
So,
Yes, sir.
so this is a first formula, which is, how do you calculate moles? Like, how did you figure out that you had 0.15 moles of sodium? So the way you do it is, it's the total mass of the entire thing and plus, plus kya karna, that's 1 second. Plus divided by the molar mass. So that is going to be my first formula, which we're going to use. ठीक है, तो ये पे कल डिस्कस करते हैं, ठीक है, this thing. Just remember that's a very important formula. Moles equal to mass divided by molar mass. Okay, so we're going to discuss this, and we can measure the moles of any substance if we know the mass of that substance, and I know the molar mass, which is the mass that is given in the periodic table, which has been accurately calculated already. ठीक है, तो इसके ऊपर कल practice करते हैं. But remember this, going back to this, most mole questions at the end of the day, if you ignore formulas, it's just this: you know the moles of one substance, you can figure out the moles of all the other substances in the equation. It's like a recipe. If you are able to figure out the moles of any one of them, you'll be able to figure out the moles of all the rest in the whole equation, entire equation. तो ठीक है, कल डिस्कस करते हैं. कोई क्वेश्चन तो नहीं है इसका?
No, sir.
Sir, you upload. You said that you uploaded assignments, but I don't know where I can get them from.
No, भेज दो. It's in the drive. ठीक है, I'll share it with you.
Can you add my Gmail? I can send you my Gmail, my ID.
ठीक है, वो मुझे आप सेंड कर दो. I'll probably will share the link to the board. ठीक है, but send the message to me and I'll share it with you.
Okay.
Okay, then take care. Office.
Officer, is there organic things today?
Organic. I'll just start in 5 minutes. You can just give me 7:45. Like in 7 minutes, I'll start organic. ठीक है.
Okay, sir.
इसी लिंक पे,
Office.
ठीक है. चले, okay. Office.